question 2 sub 1. So, check the injectivity and surjectivity of the following function. So, I am not going to do all, but I will show you how to do because all of their approach is same only. So, let us start with the first one, that is 2 1 from f natural to natural f of x defined as x square. So, I have taught you earlier that a simple square graph with no intercept, you see this is not x square plus 2 or plus 3, there is no intercept. So, this graph is a simple straight if it is real. When the domain and codomain is real, then the graph would have been like this, simple. But as the graph is not, as the set and domain and codomain is not real and natural, then how will it be graph? Let us make this solution table to see. So, this is x and this is y. So, if I take 0, so natural number will go from, so natural number is generally from 0 to 0 1. So, natural number will be from 1 2 3 and so on. This is number set of numbers which generally the counting numbers. So, now if it is 1, I get here 1, if it is 2, I get here 4, if I get here 3, I get 9 and so on. So, now if I try to plot, how will be the graph? Will the graph be continuous or not continuous? Let us see. So, let me erase this one first. What do you think, the graph will be continuous or non-continuous? So, let us say when x is 1, y is 1, that means see the graph is starting directly from here only, this being 1, this being 1. When x is 2, y is 4, so 1 2 3 4 maybe somewhere. So, you see this is not continuous because there are no values. So, this is 4. Okay. So, if I now draw a line, now to check whether this curve is whether this is a just a minute, whether this is now whether this is one injectivity test. Let us go for the injectivity test. So, for the injectivity test, there is 1 1 or not. We have to draw a straight line. So, if I draw a straight line, yes. So, x is 1 is a 1. So, I draw a straight line through 1. So, what do we see? So, for x equals to 1, there is a corresponding value y. There is this image y, right. So, for x there is a corresponding value y, that is x has an image. What about 2? 2 also has. So, that means all element for all x, from where x is from the domain, no. So, x from all x element of from domain, or we can say the natural numbers, there exist, this is a symbol, there exist a y element of n only, right, for all, and it is unique. Hence, f of x is 1 1 or it is injective. Now, is it surjective? To check the surjectivity, first you check is the curve continuous or not, is it surjective or not. The curve you see is not continuous. If the set was real, if it was real, then the curve would have been like this, as I told you in the beginning only. So, curve would have followed like this, but it is not real, it is not real, right. So, what about values like 2? There is no corresponding value for x, because if 2 you take, it is going to give me 1 point something, which is not there. For, so how are we going to write? For y equal to 2, there is no pre-image or x element of n. Okay, we can see mathematically also, if y equals to x square, so x must be equals to, what we can say, y equals to 2, what should be the x? X should be, so y equals to x square, that means x is equals to root over y. So when y is 2, that means when y is I take 2, x should be root over y, but root y is going to be 1.4. so there is no, so 1.4 is not the element of n, hence so we can say that for y equals to 2, there is no pre-image or x element of n, right, in the where, in the domain. Hence f of x is not onto. Simple, clear or not?